When my kids get old enough, I think I'm going to pay them bounties on the books that I think they ought to read.
Pay them bounties?
Yeah. So you read the book, you give me a, reasonable book report, and I'll give you $10 or whatever.
Okay, then one of those books has to be Punished by Rewards, which is about how extrinsic motivators are problematic.
This episode is sponsored by Rackspace. Are you looking for a place to host your latest creation? Want terrific support, high performance, all backed by the largest open source cloud? What if you could try it for free? Try out Rackspace at rubyrogues.com/Rackspace and get a $300 credit over 6 months. That's $50 per month at rubyrogues.com/Rackspace. DevMind is a software design and development studio in Chicago with expertise in Ruby, JavaScript, and Clojure. We believe that well-crafted software makes life better, and our team of designers and engineers is dedicated to that pursuit. We love our customers, we love our team, and we spend a lot of time and effort making sure that we fit the right projects with the right people. Get in touch at devmind.com. That's DEVMYND.com. Hey, everybody, and welcome to episode 156 of the Ruby Rogues podcast. This week on our panel, we have Avdi Grimm.
Hello from Yorklandia.
David Brady.
I think Lisp programmers should be called Lisperers because they're always using parentheses.
James Edward Gray.
I have no response to that. Good morning.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that is Julia Grace.
Hello from sunny Palo Alto, California.
Do you want to introduce yourself really quickly for folks who don't know who you are?
Sure. So I run engineering at a fabulous company called Tindy. No, it is not Tinder. It is, you spell it Tindie. And we are a marketplace for people who are building indie hardware. So think people who are printing their own circuit boards, people who are making drones, robots, add-ons to awesome projects that you can build with Arduino and Raspberry Pi. I started the engineering team there. I've grown it to several individuals. My background is all software. I started programming when I was very, very young and have never looked back since. And now I've increasingly gotten into hardware programming.
I have a question about indie hardware.
Sure.
Is Arduino too mainstream now?
So I think that the answer is depends. So,
I'm just being in the door.
I mean, I actually have very, very strong feelings, and this is kind of one of the larger hypotheses that I have about the current state of hardware is that I have a lot of friends who are very intense electrical and mechanical engineers. And for them, Arduino it's way too like playing in the sandbox, like it's for the kids. But the flip side of that argument is that Arduinos have enabled a huge class of people who previously would not have had access to hardware, the ability to mess around with a circuit board and start programming. And so when you think about declining cost in terms of both monetary, but also access to technology, it's really revolutionized the space. And because of that, ideally, you have people getting into computing who wouldn't have before, and those will be the future software, mechanical, electrical engineers, and it will diversify the landscape.
It really does seem like we're in a revolution of hardware right now.
I definitely think so, but I have a lot of skin in the game. But even from when I started messing around with this stuff many, many years ago to today, a lot has changed, and I think changed for the better.
What do you mean by indie hardware?
Hardware that is made by people who don't consider themselves professional hardware manufacturers. So that could mean anything from someone in their garage that is doing this on nights and weekends to somebody who stumbled into the tech shop, if they have a local tech shop, which is, for any listeners who are unfamiliar, it's kind of like a hacker makerspace that gives you access to a lot of very expensive machinery. You pay like a monthly fee. You can take classes, that sort of thing. So it might be somebody who started getting into hardware there. Mm-hmm. Or it could be somebody who very strongly self-identifies as like a hardware quote unquote person. And we can talk a little bit more about that later. But they never really thought about selling or even like giving their hardware to anybody else outside of themselves. But now, like with the rise of the indie hardware movement, they're able to do that. So long story long, probably I think indie hardware is anybody who's not doing large scale manufacturing, like people who aren't at Foxconn, which is the factory that Apple uses to produce a lot of the Apple products that you may use and love or hate.
So indie hardware is people producing hardware products then?
I think it's people who are producing and then people who are also consuming as well. Like I think to have a movement, you need both producers and consumers, because if you're just producing, it's like broadcast. So you need people actually like listening to. So that's how I would define it.
Okay, that's awesome. I do a lot of hacking with, not so much with Arduino, but with like the Teensy, which is it's an ARM chip.
Yeah.
ARM chip. And, just hacking little dingbat motor controllers and stepper controllers and little LED, displays. And I'm like, wait, I'm not actually producing anything to give to anybody else. I'm just making little blinky lights that make me happy. Does that count as indie hardware?
Yes. Yeah. Oh, I mean, absolutely.
Okay, excellent.
You would love the stuff we have on Tindy. And you also, I mean, I'm not trying to like be that person to like plug their own company, but I just actually genuinely think that you might be interested in this stuff and the conversations that go on. And you don't have to sell what you've made, but I think you might be excited by what's available and inspired. So
that's awesome. Also, this is a common misconception with Rogues, and I'm going to say it on the show so that anybody following you can benefit from it. We have an implicit, and it's now an explicit rule. If you built it, you can plug it.
Okay, cool.
Okay, plug Tindy all you want, because I had not heard of it until you mentioned it a few minutes ago, and you're absolutely right, because I'm a tinkerer and I love hacking, soldering, etching my own circuit boards and that kind of crap. And I've made a few smoke emitting diodes in my day, and having a resource where I can go to and find out, because I don't have, like you, I've got a software background. I did a little bit of hardware with ham radio, when I was a teenager. So that was back pre-digital days. Everything was, amplifier, transistors were used for amplifiers rather than switching. And so I didn't understand things like ground loops and, that kind of stuff. So yeah, Tindy sounds really awesome. So by all means, plug away.
Okay, thank you.
So, Julia, you've already kind of hit on one of the major things that kind of has been pushing the hardware movement so well, like Arduino. There's definitely other things like Raspberry Pis, and many similar kinds of branches off of both of those. And 3D printers are becoming kind of a big deal. And just the other day, I saw this article in Wired. I'll drop this in the show notes, but about a completely open source laptop, which was just amazing.
Are you talking about Bunny's open source laptop?
I don't think
there's like several now.
Wow.
Or maybe we're talking about the same one. Sorry to interrupt you.
No, it's cool. I mean, it's just I was surprised from you could go down and see like the diagrams of the boards, and just all the way down, completely open. Really cool stuff. So, what's going on here? Why is this exploding all of a sudden?
I think there's a lot of different explanations. My personal belief. So if you look back like a decade or so ago, or even further, opening up your microwave or your toaster oven or your coffee maker, the only people who did that were like crazy mad scientist types. And so it wasn't cool to show off your circuit boards. Like circuit boards and wiring and all of that stuff, so to speak, was hidden behind a nice, shiny, fancy case. And so when Arduino came out, and one of the creators of Arduino, he's a designer and he specializes in visual design. And so there's a reason why those boards are blue, why he chose certain colors. He wanted the boards to look good so that people didn't feel like they had to hide them beneath a larger encasing. And so what has started to happen is suddenly it's cool to flaunt your circuit boards.
Nice.
And so when society started realizing like, hey, there's some really cool stuff going on under the covers and it's not just like a junky mess. I mean, sometimes it is, but 9 times out of 10, there's some really cool stuff going on behind the scenes, and it's okay to want to know what's going on. And it's all right that you as an artist, like, even though you may not self-identify as an electrical engineer or a mad scientist or a quote unquote hardware hacker, but you as this maybe like a budding architecture student, like it's okay for you to look under the covers and it's good, and we encourage this experimentation. I think that started to drive the larger movement of, oh, if I publish my schematics for what's going on under there, this is actually cool because like I've started to learn that some of this hardware is actually like approachable and really awesome. And I think that is kind of what led to this, like the larger, one of the many pieces that led to the open hardware movement. It had predated Arduino, but I mean, I think that's why it became more mainstream. And then projects like Bunny's Open Laptop and some of the other stuff that you're seeing, why society largely embraced and promoted those types of projects instead of it being so niche.
That's really awesome. It's kind of leading to this maker culture. Do you want to talk a little about that?
Yeah. I mean, it's kind of funny. I feel like it's almost, I see a lot of people now who kind of self-identified as like, I'm a nerd. And now like, nerd became cool. And now everybody's becoming a maker. And I think that's good. I don't think that, I think there have been larger societal trends, as I had hinted to before. But I think that like, maker is a good thing. And I think that people are starting to dig into hardware, software, and other mediums, and then realizing like that there's a word for this, and the word isn't scary. It's actually fun and cool and comforting. And so I think that that's kind of this larger like Maker Faire, for example, is a large event that's put on by Make Media, which is, I believe, part of the parent company of O'Reilly, and O'Reilly publishes a lot of those fabulous tech books. And I've seen some of the Maker Faire like promotional like documents that they've put out. And to some extent, the fair is like exponentially growing in size and participants. It almost feels like, even though I hang out with a lot of people who are like very quote unquote makery, it's only just the beginning of a huge trend where I think that even later on, people who don't classically view themselves as makers will then start to self-identify with that term.
That's an interesting point, kind of the trend in that direction.
Yeah. Now there are a few maker shops around here where you can, like you said, you sign up, you pay a monthly fee, and you get access to their equipment and things like that, their CAD programs and whatever. I'm kind of curious, are there good places to get started with that kind of thing, like picking a project that works out well, or kind of understanding the basics of how to start hacking hardware?
Yeah, absolutely. So I think that you've kind of touched on one of the really big challenges right now of the like quote unquote maker movement, that it would encompass like Arduino, in some capacity Raspberry Pi, and BeagleBone, which is another type of board that Texas Instruments sells. You have all these people who are self-identifying as software people. And maybe these like software people, and myself included, where my degrees are in computer science, not in computer engineering. And so you've got this like group of people, and a lot of these people may even have kids too, that they want to start getting their kids of all ages into this. And they don't really know, like, how do I find my gateway drug into hardware hacking? And they feel very intimidated by getting into this stuff. And so one of the things that I did was I wrote, and I put this in the tips and tricks, I think maybe it's just tips for the episode, of how to make your very first Arduino program. And it's designed for people who know how to program, but not anybody who's ever touched an Arduino before. So I put that in there. So if you want to, and you create you set up your board, and you can press a button on the board, and it sends a text message to you. And so that was kind of a fun V1. And then the code's on GitHub so that you can fork it and you can like play with other libraries. And this is in Python. I know that this is a Ruby Rogue titled podcast for a reason.
Python friendly.
But
we're Python friendly.
But then what's so cool is that I'm fairly certain, though not 100%, that you could do the same thing and write Ruby on an Arduino, because you can put a different firmware on there, and that will enable you to write almost any language. And so where this has really taken off is with JavaScript. And so there are people writing JavaScript. Oh, and this is like I find this the most interesting, and I honestly think this is the future of hardware. So the JavaScript community has gotten super into hardware hacking with the NodeBots movement. So NodeBots are programmable robots with servos. They usually have different boards, and they fight each other. so I mean, there has to be, if this is, I mean, come on, we're talking about like nerdy engineers. There has to be some element of like nerd competition. So people will program the boards in JavaScript, and I have the links to NodeBots in the tips. So I think that like the gateway drug here is, instead of like, oh my gosh, I now need to learn how this whole entire skill set of like how to solder, how to know if I have too much current running through my board. Like you can actually take languages that that you may be comfortable with already, Python, Ruby, JavaScript, there are probably others, and write those languages on your board. And then as you get more sophisticated, you can then maybe drop down to other languages like processing, which is the language that is most commonly used with Arduinos, that was originally designed to be used on an Arduino. So that might be a little bit more powerful. But I honestly think the future is going to be people writing JavaScript on hardware. And there's a few boards that come out where your language isn't even compiled into C to be run. It's actually, they have a native JavaScript compiler on the board. So anyway, so that's kind of a long answer to like, how can I get into it? And then you've kind of got this whole other world of like really expensive but totally interesting equipment. And what would fall under that would be 3D printers, laser cutters, CNC machines, all this interesting machinery that would be available at a makerspace or a tech shop. Or something like that. And what's best that I found, if you want to get into 3D printing, and a lot of people, everybody is like talking about 3D printing these days, or at least maybe I live in a bubble, but I feel like I've read a lot about 3D printing, especially with MakerBot being acquired by a larger parent company. Everyone's like, we all must 3D print everything all day long. So I would encourage you to take like an introductory class in some of this stuff, because when you use a 3D printer, it can take a really long time, especially if you're using a MakerBot or a consumer printer, to print something. And a lot of people don't understand that, like, you're like, hey, I want to print like a really cool piece of jewelry or some earrings, and that can take like hours to print.
Yeah.
And there's often, and I hate to bring this up to like scare people, but there's like a lot of fumes that come out when you're printing plastics. And so you want to be careful. So you don't want to like lean over the printer and then like inhale all these fumes. So, I mean, even though it's like really cool, you just have to be careful and use some common sense. But laser cutters are also like super rad, and you can like cut all this amazing stuff. But, there is a little bit higher barrier to entry on some of that. But a lot of the 3D printers, a lot of them are there's many that are open source that use Arduino boards. So you've kind of got this full cycle of like, you can start hacking on Arduino, and then you can see how there's actually like a copy machine that's like all made out of Arduinos, like where you like copy documents. I know that's so like 1990, but like that's like a thing. So those are a few ideas to throw out there.
So I thought I would mention my own experiences, because I think I made pretty much all the mistakes getting into
but do tell.
hardware. Really, my first big attempt was getting into like a Linux media server at home. So hooking up, like a media center, and then tying that into like everything in your house, so your music can follow you around the house, kind of stuff.
So not just like Myth TV. You were actually like Myth TV plus.
You're right.
Smart home before it was cool.
Right. And
you had to use Linux.
Right. I had to use Linux, exactly. So I kind of got into that and had various success. I did not like the media server and Linux stuff, and it was complicated and way too much to figure out, and I got stuck. I did enjoy figuring out like Insteon stuff. So my light switches are wired in my house now, and I can control them through my computer. And
that's so cool.
Yeah, like my laptop. When I come into my office, I just turn my laptop on, and it turns everything on. It's kind of neat. So things like that. That was kind of my first foray. And then eventually I discovered the Raspberry Pis shortly after they came out and started playing with those. And to me, that was an easier barrier to entry because a Raspberry Pi is just a little Linux box, right? And most of us probably know the basics of setting that up, and it takes like 4 hours, but you can compile Ruby on it and then just use Ruby. And so it's Ruby, and I know what I'm doing, and even interfacing with the GPIO, which are the pins that let you talk to everything on a Raspberry Pi. That there's libraries for that now and stuff, so it's great. And I believe there's binaries now too for the Ruby, so you don't even have to do the 4-hour compile. So that to me was a little bit easier barrier to entry, and I had some fun playing with that. But then the thing that really got me into it and led me to ask Julia to come to this episode is we did do a 3D printer. And that, she's right, the barrier to entry is a lot harder, but I got smarter. And first I went and found somebody who was good with electronics, a friend of mine, who'd like built his own amp and stuff like that. So he knew kind of that side. And I said, I know the software side, and together we'll see if we can figure it out. And we just bought a kit from a company, and they don't do the kind of kits we did anymore, but we bought a kit and, assembled the hardware. And then actually assembling the hardware is an easy part of making a 3D printer. That's the really easy part. The hard part is you have this program that's communicating with it on your computer. And then you have this slicer, which is a different program that's dividing up 3D models, and that's communicating with the program on your computer that's communicating with the printer. And then you have this firmware on the printer that's interpreting all these messages that are being sent and actually running the printer. And the really hard part is getting all three of those set up in sync, talking to each other, properly calibrated. And a couple of years later, we're pretty close. No, we have actually been printing for a couple of weeks now. We've had some pretty good object prints, finally got over the hurdles and stuff. And it's neat. Like, boy, I can't tell you how much we learned setting it up. We read like half the internet, I'm pretty sure, to, figure all this out and learn things about hardware and software and how everything communicates. And it was a really awesome experience. And actually we're doing in June, a local group around here that does a regular, teaching series are having us come in to show our 3D printer, and we're going to go show it printing something.
Have you document? You should write this up about like your experiences and what you used, and like if you haven't already.
I haven't. No, I do need to write it up. You're right, because I have learned a lot, and it was a tough experience. If I were to give anybody a piece of advice on what I've tried, I would recommend starting with something easier than a 3D printer, just because there's so many steps, and it's very hard if you don't have a good idea of what you're doing. We did succeed, but like, I'm not exaggerating when I say it took like a year and a half to get there, And
one intermediate step, maybe. Julia, you talked about laser cutters. Mm-hmm. I'm experimenting right now with a really low budget, and by low budget, I mean about $300. So, I mean, this is kind of a high ticket item for consumer, but it's not it's not a $30,000 laser cutter. And that is, I went out and got a programmable stencil cutter. And this is a thing that two big ones out there. There's the Cricut and then there's the Silhouette. And these are not being sold to makers. These are being sold to homemakers, scrapbookers, right? They basically cut fabric, cut vinyl. And I'm like, wait, cut vinyl. I have stickers on my laptop, and those are made out of vinyl. Mm-hmm. And I went out and researched, and Cricut takes hardware cartridges, and it's kind of tricky to hack on the Cricut. But there's a competitor to the Cricut called the Silhouette. Again, they're not catering to makers yet, but it will take SVG files. And that means I can open up Inkscape on Linux and I can draw anything. I can take a Photoshop vector image, whatever, and I can program it. I can stick it down on this thing and I can cut a piece of vinyl with it. And now, for one thing, I can cut a piece of vinyl, stick it on my laptop, and I've got a cool sticker. Or I can cut a piece of vinyl and stick it on a piece of copper plate circuit board and drop it in the etch tank, and I've got a circuit. All of a sudden, there's some really interesting options opening up. I'm not ready to give a full report on how awesome or not the Silhouette is for this yet. I haven't hacked it really to its full extent, but I'm very interested and excited to see what the possibilities of abusing this product, in a manner that was not intended by its manufacturers.
I think you've touched upon an important point so we've got these great new technologies that are coming out that are being used in ways that were not originally designed or maybe even originally thought of by whoever manufactured them or whoever sells them or whatever. But I think that means like when you see people, and I guess the word would be like kind of hacking these devices, like that's when some of the coolest innovation, even though that word is a little cliche, but I mean, that's when like the innovation begins, is when, and so I think that the examples that you all have described, like, I think those are like some fabulous ways of what we're seeing. But I think in the future, doing the types of projects, the smart home, I've seen like the market for people doing things with laser cutters, like laser cutting wedding invitations, and that market is hugely growing. And so it will only become easier as mainstream society starts to see the incredible uses, like in medicine, for example, for 3D printing. Because I think in the beginning, a lot of people viewed these technologies as kind of like cute and fun and like playful. And the Raspberry Pi, that's the computer for your kids. And then people started using the Raspberry Pi as a Tor proxy. And so you see these technologies being repurposed and used in ways that are no longer necessarily for fun and games, but maybe you're conducting commerce on Tor.
Yeah.
So
commerce. That's what we do on Tor.
Exactly.
Yes.
But I think that so the people who are identifying themselves as kind of like the makers and the hardware hackers, those are starting to be the glimpses of what might be possible in the near term or maybe longer term future by people who maybe don't have the necessary like skills or time to do the 1.5 year deep dive into smart home. But I've had friends that have set up like some sweet kind of like, what would the word be? Like a video camera to take a picture when someone delivers a box to your house, and then it like texts you. And they can do this for like under $50. It's not very difficult. And like that was just impossible to do like 10 years ago. And so like, I think this is just like really changing the face of what, like, it's empowering a group of people who never thought that they could do this and it was probably not only knowledge prohibitively, but like cost prohibitive before.
Yeah, that's a great point that you talked about 3D printers being used in like medical applications, and I'll add this link to the show notes. But yeah, I was reading a great article recently about how they used a 3D printer to help model a damaged esophagus, and replace this young child's windpipe. And they're getting used everywhere. But what's weird is once you have one, I'm just hitting the stage now because I just recently got to the part where I can reliably print what I'm trying to print. And you start, right? Yeah, embarrassing, I know. But you start to get all these ideas like, my wife and I are big board game players, and we love board games. And anybody who's a big board game nut knows that they come in these like horrible boxes where they have like 50 million pieces and 3 slots, and there's no way you can put them in there in any reasonable way. But so now now that I have my 3D printer, I've been using Blender and playing around with different shapes that would fit in the space inside the box so that I can properly store the pieces, and the idea that I can just sit there in some 3D program and play with a model, and then when I have it right, I can save it as an STL, send it to the slicer, and it's going to pop out of that 3D printer. It blows your mind.
That is so cool, because that's what I'm doing with the Silhouette, where I'm looking at containers that are the wrong shape, and I'm folding a piece of paper to about the right dimensions, and then unfolding that piece of paper and then saying, okay, Silhouette, cut me exactly this, but out of this stiff stock weight paper. And then I fold it back up into back into the origami box, and it's got custom, rounded box compartments inside the paper. And yeah, it's not what these things were meant for, which is awesome.
Yes. I actually think, I always draw the analogy of like, when we saw the first cars, like when Henry Ford first created the first cars, like if you needed to get the car repaired, you needed to know what you were doing. Like cars weren't necessarily like, yes, they were for people who maybe had a lot of money, but you also, you needed to know what was going on under the hood, because your car could break down in the middle of nowhere and you had to be able to fix it. And now that's not the assumption. Like you go and you buy a car, and I don't know how to change the large battery in my Prius. Like I know how to change the other battery, but I don't know how to I can change my oil, but I don't know how to do all the other things, because I assume the car to just work. And I think in the future we'll buy these things and then they will just kind of work, which then brings up the thought of but then people will find different ways to kind of hack them and do other things. And so that will ideally lead to more cool projects and that sort of thing. So I feel like if there's a listener listening to the podcast and they're like, oh my gosh, I can't even imagine myself hacking my 3D printer, but don't worry, there will come a time when these will become so commoditized that you won't have to worry about hacking it, and you can just print your Settlers of Catan pieces when they fall into your heat vent. So
right, exactly. it's already largely like that. You have sites like Thingiverse,
yes,
which just has tons and tons of models ready for you to print. So
That's
if you have
and Shapeways, where you can just have them printed, so you don't even own the printer. Yes.
Yeah. So if you have a common need, so one of the first things you find yourself wanting when you get your 3D printer up and running is a spool to hold your print plastic, so that it will just spool off cleanly if you queue up a 17-hour print, and you don't have to stand there like an idiot holding it, right? And
inhaling the fumes. Yes,
inhaling the fumes, right, exactly. Which may be where some of my problems come from. But so like Julia says, you just go on Thingiverse and there's spools all over the place, and you pick one and it's a model already, you feed it into your 3D printer, and your 3D printer will make you the spool that you need to print with your 3D printer. It's cool.
There's a thing that I love, Star Trek, right? The Next Generation and Voyager and Deep Space Nine, whenever they want to show one of the engineers working on something, he's pulling out the isolinear chips, right? And they're just these little pieces of plexiglass, right? But they're colored. And the way the engineer is programming them is with this little flashlight that goes when he points it near the chip. As a programmer watching this 10 years ago, I'm like, there's just no way a single point and click tool can program everything that we need. But look at the Arduino and the fact that you can just stack shield on top of shield on top of shield. We're really close to having isolinear chips. How far away are we from having FPGAs, these field programmable gate arrays, which are chips that you can reprogram using electricity? How far away are we from having basically a set of Lego blocks that you can stack together and point a little radio at them and beam radio energy at a certain frequency to change the chip from transmit to receive, or to change it from emit the red light to emitting blue light, or change frequency or change resistance or whatever? We're not that far away from it. And when we start to get close to this, we're already seeing one of my picks is going to be the Teensy chip, because I thought I'd picked it 9 times, but I haven't ever picked it on the show. One of the beauty things about it is that all of the outputs are internally limited, which means that you can accidentally solder one of these suckers to ground and then tell the chip, put power to that thing, which 5 years ago would blow out your whole circuit, and you'd be testing.
Toast.
Toast. And you now have to check everything every single component of your circuit has to be tested to see if it cooperated in the overload and, by destroying itself. But now the chip just goes, yeah, okay, you're going to get 80 milliamps and I can give you that and you're not going to get any more than that. And we're done. I mean, you can ship the thing. I mean, the rest of the circuit works fine. And you've actually got this thing that's trying to burn itself out. And that combined with, so we've got the little Legos. We've got the ability for people who don't know all of the arcane secrets of electronic engineering and all the wrong, we still have to do things like put a diode across your motor input. Otherwise the flyback is, 2000 volts and that'll fry your chip. Okay. But you can learn that. And 2 years from now, they're going to ship Lego motor interfaces that have diodes in them also. And so that you don't have to know it anymore. You just plug into Lego and you get your little radio and you go, and you're done. And that is so exciting because the future is coming.
Yes.
I feel compelled to point out, since David used Legos so often, Legos can also be a pretty common tool in just custom hardware hacking. I'll drop a link in the show notes just for Lego cases of Raspberry Pis, for example. And I've seen tons of them built like clusters where you put tons of pies in there and then use them for various purposes and stuff. But Legos are surprisingly useful in almost any building scenario.
And you can print them,
Yeah, exactly. If you have
Here,
a 3D printer.
it's all those like ridiculous copyright laws. That's a subject for a whole other conversation.
Right.
Within your, in the confines of your own home, you can do what you need to do. So, yes.
Yeah, that's a great point.
Do you ever do any lower level programming stuff? So my background, I actually have a degree in computer engineering, which means that I designed my own spy bus in college, did a bunch of chip design, wrote some drivers, with C and assembly, and then you kind of move up from there to, actually building on top of those drivers with a higher level language like JavaScript. Do you see people doing the lower level stuff as well?
Yes. I mean, there are absolutely still people who are definitely, who love writing, lower level C. I haven't written like low level C in a very long time. It's always going to be important to have like that sort of skill set. But I mean, increasingly, and I posted this in the pics, like there's a name for this whole, like, we're all going to be writing JavaScript in the future. And what was it? Atwood's Law. So when Atwood's Law, Jeff Atwood, I don't know if the word would be proselytized, but maybe issued an edict that in the future, anything that can be written in JavaScript will. And so we're kind of reaching that point. And so the name of this movement, said by a very smart man, Alistair Allen, who is very big in the kind of circuit board, Internet of Things. He was at Google I/O doing some really cool stuff. He said, the web developers are coming. And so, like, the hardware community traditionally has been composed of people like you had mentioned, kind of lower level hackers, people who are really interested in like kernel hacking and that sort of thing. But like, I primarily hang out with like a lot of software engineers and a lot of web developers. And like a lot of, there's this huge influx from the web development community. But, I think that we're not quite there yet. Like, we're not quite to the point where you can just like turnkey switch write JavaScript on a lot of these boards. And so a close friend of mine, she is building some, to give you a concrete example of somebody who had to drop down to C. She's building some really amazing jewelry for teenage girls that you can reprogram, and it'll light up and it'll like do different things. And so the thought here with this jewelry is that, you've got something that has a very large appeal to a young female audience, but it can be hacked. And so she wanted to encourage the girls to start using it. And so she started building like the very first prototypes, and she wanted to use a higher level language to program a lot of this stuff. But when you start to move away from Arduino and you're thinking about making a product that's going to need a manufacturing run, like nobody who builds hardware at a larger scale than like I'm at my house kind of messing around, and maybe like a few larger projects, like I mentioned before, the copier. But like if you're going to build something to sell at large production, you don't use Arduino. Arduino is too expensive. You usually need a more specialized board. And some of those more specialized boards will have components like you need to communicate with the Wi-Fi adapter. And the only way you can do that is in C. And so for her to make this jewelry to make it cost effective, to make it like just work. So the girls will not be programming in C, but they're probably going to be using like a higher level language. But for her to make that jewelry really turnkey for the end consumer, she's had to write a lot of lower level stuff right now. And it's really amazing. Like she did some like super, super cool stuff, and there's like bracelets and they like light up and you can like have them tweet. It's just like mind blowing. But yes, I think you absolutely, like if you really want to be doing some of that low level stuff and you want, and even if you're like, wow, I actually like want to have this manufactured, which is like a whole other discussion, which I've learned a lot about, but for another time, then you need to be, you absolutely need to know a low level programming.
I feel compelled to point out, due to us talking about how everything that can be written in JavaScript will be written in JavaScript. If you have not yet, you need to go watch Gary Bernhardt's talk.
At PyCon?
The Birth and Death of JavaScript. It's very, very good.
You said funny. There's in the future, everything that can be done in JavaScript will be done in JavaScript, and there's a word for that. And the first word I thought of was Lovecraftian. I guess I need to go watch these talks because I mean I've been very vocal in my disparagement of JavaScript, but if my choice is become a dinosaur or move with the times, I guess I'd better evolve so that I can survive the JavaScript meteor.
Jim Wyrick, a good friend of all of ours that passed recently, he went to the Nodebots stuff. I believe when he was in England for like Scots Ruby or something like that, and he went and attended their groups, and then he came back and was redoing all that stuff in Ruby, and that's what got him playing with the robots and stuff. So that's kind of interesting.
If you have more information about like Rubybots, that would be, please do share, because I think to your earlier point, like. I think that eventually, I went to a programming conference. I spoke at a big web development conference in New Zealand last summer, and it was language agnostic. So, I brought some of my slides had some Python. I figured somebody's going to be writing some Python. And basically everybody at the conference wrote JavaScript. That being said, some of them did some Ruby, did some Java, did some Python, did some C#, did some C. But that was like, everybody was like, I always, regardless of my job, I have to at some point in the stack, in my job, deal with JavaScript. And I was like, I should have given a JavaScript talk, like to be completely honest. So whether we like it or not, I feel like this is kind of where, but please do share any Ruby bot stuff.
There's a lot of like Python has like a TinyPy. And, they've got like a stripped down version of the interpreter. We do actually have a TinyRB. It's Ruby has a lot of really crazy, awesome features that are really hard to implement in a tiny kind of firmware. Mm-hmm. But, things like TinyRB, where you get rid of the really dangerous stuff like eval and, the ability to throw lambdas around and that crazy stuff like that. I think that's probably really doable.
What about Ruby? I didn't pronounce it well. Ruby?
Okay, yeah. I what about Ruby? I'm like, that's...
It's a joke. A joke from a conference talk. I can't remember who gave now, but yeah. Ruby is meant to be embedded, right?
Oh, perfect.
Yes.
My main interface with Ruby is Chef.
Sure.
And we've recently started using Discourse, which is also from Jeff Atwood of Stack Overflow fame.
We use Discourse as well with the rogues.
Yep.
Yeah. Oh, very cool. Very cool. So those are whenever I need to write Ruby, it's because we're debugging Discourse or Chef. So I always have a tainted view. But when it works, it works.
Yeah, you want to hear a dirty secret? I actually have a recipe in Chef Solo to deploy Discourse. So.
Oh, nice. I think yeah, I mean, that's what we use to control all our boxes. Or we're using, but yeah, we just spun up another VM and put Discourse on it, and it was fun times. It's very great software. So.
I have a couple of more questions just related to my own experience and kind of see where you fall on this. One of them was in high school, we were doing stuff with like 8081 or 8085 chips and sending messages in. So you were basically sending assembler bytecodes in to the input pins and then turning on LEDs and making it count and stuff on the other end. It seems like things have gotten a little bit more sophisticated these days. I mean, I was in high school, 15 years ago? So I wonder, to what level you see people just, buying a set of components, sticking it on a breadboard, and just hacking with things that way.
You mean as opposed to?
As opposed to getting like an Arduino or printing their own circuit board.
I think it just depends. I'm trying to think about how to best answer your question. I think it depends on who they are, on what their peers are doing, on what they have access to. I think so. There's some really amazing places that have a lot of really great tutorials. But I think what's tough about that I see with a lot of the like younger students I work with, and I don't even mean like high school. I mean like even younger than high school. Is it like, I have so many kits with LEDs and capacitors and like buttons and lights and all this stuff. But if you don't really know where to begin, then it's hard to know how to build a circuit and where to put the capacitor and how to program it. And so I think a lot of it, I think it's very dependent on what the young person and old person, if we're all old now, I guess, what they want to accomplish and what makes them excited about what they're doing. Because I think there's always going to be people like yourself. But I think that what's cool is there's now a lot of other things that you can do that involve immediate gratification, where make something light up or, turn on your lights or do something. So, I don't know. I don't really know what the future holds. But I think the good thing is that when there are more options available, then that means hopefully more people will get interested in doing these sorts of things. And then we'll have a whole another awesome generation of people doing this. And I don't know if that completely answers your question, but, I never did any sort of hardware up until like several years ago. I took physics, and that was like my only introduction to like electromagnetics and optics. But I never messed around with like low-level circuitry until I was a fully formed, functioning adult. I don't think we were fully formed and functioning in college. Maybe some people were. But I think what excites me the most is that I have a friend who is also named Julia. And she, and I talked about this in my future Stack Talk, so I apologize if you're hearing it again, or if I sound like a broken record, but I think it's very important and very like kind of mind-blowing. And she runs these tech camps for teens, and these are primarily for teens, and she's in North Carolina, and these are for teens who wouldn't have had access to computers at all. And she sets up Raspberry Pis, which are obviously like very low cost. And the teens come in and they program on the Raspberry Pis. And it's just like so eye-opening. And it's just amazing to see how like mind blown they are and how they're suddenly like, wait, even though I don't look like all of the cool programming nerds, like I can be a programmer too. And like, this is really cool. And it doesn't have to be about, like you don't have to be that hardcore person that uses all those words that I don't understand, or because they were like being nerdy for like the end of time, like they like came out of the womb being a nerdy. Like I, as this person who may not self-identify as a nerd, I can still do this too. And so I think regardless of how people engage, it's more about that they are engaging in the first place that is the important thing.
That's really cool. I when I think about a lot of these current maker trends, a lot of times the stereotype I think of is kind of, I guess what I think of as first world toys,
Yes.
Some little device that, I don't know, like tweets how long it's been since you've eaten bacon or something. I don't know.
Yes.
Wait, you don't have that?
But I wonder, I mean, do you feel like this democratization of hardware hacking, do you think it's gonna pan out beyond that? Do you think there is a potential for some more fundamental world changing?
Oh, I mean, I absolutely do. I mean, and I think that the reason that will happen is because of the decrease. I think that like the lower barrier to entry in both cost since you can now do this, as we had discussed earlier in the podcast, it's such a dramatically, I mean, if you can buy a Raspberry, granted, a Raspberry Pi doesn't come with peripherals, but I mean, it's a very inexpensive computer. If you can do this with cost, and since Raspberry Pi and Arduino have become more mainstream, not totally mainstream, but more mainstream, you have a lower barrier to entry. I think that we have all the pieces for change. And so, I definitely think that this is, I hypothesize that this is the beginning of something bigger. And I really hope that like 10 to 20 years down the line, when you look around at the people in software companies and hardware companies, you'll see people not only of different genders and races, but different socioeconomic backgrounds, who had access to different things when they were young. And so I think that those of us who are like nerds tend to think like, this is so cool, like Nerd 2.0, like we're now doing all these cool nerdy things, and like we have the means to spend a lot of money to like build to build all this crazy stuff, and if we break our boards, who cares? And like, but I think there's also like the inklings of the tremors of larger change in the tectonic plates of like the society structure around computing and, access to computing.
That's a fantastic point, because I think, a lot of times hacker culture kind of looks at itself as being very meritocratic, and one of the things that goes unexamined is when you look at most hackers' backgrounds, very often there was some reason that they had access to a computer before other people, or or that other people in different income brackets or whatever, they had access to a computer when other people didn't, at an age when other people didn't, and so I think the same factor could very well be the case with hardware, or with with hackable hardware.
Kind of along those lines, one of the things I've noticed about all the things I've been playing with is my 3-year-old daughter is watching us play with all this stuff. Like, and getting something out of it. Like, so when we finally got it printing, the other day, and we're making, little objects, we were looking around on Thingiverse to find something we could print that wasn't ridiculously long, wouldn't take 17 hours, and we could kind of judge how well we were doing now. So we printed a barrel of monkeys, the monkeys that you hook together arm in arm.
Oh, yeah. Yes.
With the barrel. It had all the monkeys, and then you had the barrel, and you could put the monkeys in the barrel and close the barrel. We printed the barrel of monkeys, and we gave it to, my little girl and her 5-year-old friend. We gave it to them to play with, and so they have seen us go from this box of parts that did nothing, and over a course of time, which is epic to them, we assembled it and did it, and now we can just they can pick pictures of things and they pop out of this printer, and it's kind of amazing
awesome.
that they grow up seeing this. I also had a Blink One. I don't know if you know what this is, but it's a silly piece of hardware. It's a USB plug that you plug into your computer, and it has an LED light on it, and you can control the hue and the flash rate and all that programmatically. So you can just do fun things like have it blink a certain color whenever you get an email or whatever. You can do fun things with them, and she's seen me play with that before, and we would do things like she'd be like, change it to blue, and I would invoke the command line client that changes it to blue or whatever, and just stuff like that. So I feel like she's growing up with these ideas about how she can manipulate her world in ways that other people might. I didn't grow up with those ideas,
That is so huge to realize that she now lives, her mental model of the world is such that if there is any tiny, small, hard plastic thing of any shape or size or design, well, not size, but any shape or design, I can make it. I can create it. I don't have to wait for someone to produce it and give it to me and dictate to me as the consumer how it can be used because it's closed hardware.
Or by a professional.
Yes.
Remove that notion of you have to be someone of a certain class, of a certain stature in order to provide these things.
Yeah. my father-in-law is a metal worker, has a full metal shop in his garage, and he built me a machine. It's got way too many gears and ratchets and stuff. It's a machine whose purpose is to look overly mechanical and crazy, and all it does is smash soda pop cans. But it's an insanely complicated machine, and it's a thing of beauty. I mean, it is genuinely art to watch this thing go around, and it's got a hopper that you can stack cans in, and it smooshes them and drops them out into a little, catch basin. But to me, and the mental model of my world before and after I saw this machine, it annoys my father-in-law no end, because he wants me to look at the whole machine and appreciate it as art. And I keep going there's one flywheel up on the top. It's not a flywheel, it's a pulley, a belt-driven pulley to provide gear ratio reduction from the electric motor, which is off a sewing machine, by the way. But this flywheel is made out of aluminum, and it's solid aluminum, and he cast it. And to get the aluminum for it, he melted down a screen door.
Wow.
And I
bet that was an adventure.
And so every time I go to this machine, I just fondle this flywheel and say, "You used to be a screen door." And that is such a mind-blowing thing for me, to hold this lump of metal that has been completely repurposed. Is just so exciting and happy. And that's when you talk about Summer looking at 3D printed parts coming off of this machine and realizing, oh, I want a tiny plastic toy like this. Daddy, can we make this? That's the world that she's in. That is so exciting to me.
Yeah, it's super fun too, because they get excited about it. I mean, they get really bored when you tell them, what are you doing? And we're like, we're calibrating the 3D printer. And they're like, yeah, when can we print something?
Right.
But now that we're to that phase, and she occasionally, mocks us for like how long it took us. My friend that I work on with the 3D printer was coming over the other day and to work, and we worked together. And she said, "Oh, maybe you could work on the printer," like, because that's all we do, right? Work on the printer. But it was pretty funny. Hey, I want to answer Julia's question. I'm slow, but I have her answer. The ways to use Ruby to do projects like this. There are some good resources. I mentioned that Jim got into the NodeBot stuff and then started building his own Ruby bindings to do that. He did that for the AR Parrot drone. And his bindings...
Oh, so cool.
Yeah, his bindings are on GitHub, so I will put a link in the show notes. And then the other thing, Ruby does have a great library made by Ron Evans and others who we've interviewed on the show before. And it's called R2, A-R-T-O-O, kind of like R2-D2, but spelled different. And it can talk to tons of different platforms, all the ones we've discussed today and more, like Spheros and stuff. Really cool library for...
Oh, this is amazing. Yeah,
doing any kinds of stuff. So I will put links to those in the show notes.
Because I get these questions a lot from people of all sorts of programming communities and backgrounds, and they're like, how should I do this? And I'm like, let me look into that for you. So fabulous. Thank you.
All right. Have we covered it? Is there anything else we need to say?
I'm just sitting here with my mind completely blown and just so happy. I've just got this warm glow. I want to go hack on things.
Yeah, I want to spend my afternoon tearing something apart.
Yeah, no kidding.
If any of you are in the Midwest, I'm going to be talking about a lot of hardware stuff at Midwest I/O, which is a new conference in Kansas City, Missouri this summer. So not to, I'm just always very cognizant of trying to plug things, but I think the conference will be really cool, and it's the first year of it, and I think that it just seems like there's not a lot of conferences and events for this sort of thing yet in kind of the Midwest. I feel like it's kind of New York and San Francisco and Chicago, and so if there are any listeners in the Midwest, you should check that out. And if you can't attend, there'll be talks online that you can watch, of course. So just wanted to throw that out there.
Well, that's in my backyard. I live in Edmond, Oklahoma. I'm about 4.5 hours from there, which is nothing in the Midwest. Yeah.
That's like the number. Yeah. Yeah. Love it.
All right. Should we do some picks?
Let's do it.
Sure.
All right. Avdi, do you want to start us off with the picks?
I don't have a lot this week. I did actually, read a fiction book recently, which I rarely get time for, but John Scalzi was kind of talking up this book that just won the Arthur C. Clarke Award. It's called Ancillary Justice by Ann Leckie. And so I decided to go ahead and check it out and see what the fuss was. And I really enjoyed it. It's a fine science fiction novel of the revenge against a galactic government variety. And it's good just from a pure story standpoint, but it also kind of made me think in interesting ways because it is told from the point of view of a character that for various reasons has very little perception of gender. And so sort of one of the side things going on through the whole book is I'm watching my mind I'm watching my mind want to put gender on characters in order to visualize the situations. You know, because this character basically just refers to everyone as she, because this character really doesn't, both as part of what he or she is, what it is, and what and the culture that it exists in. And I can say it because it used to be basically an AI. Although I guess that's a problematic statement too. Wow, this is a whole world of fish. Anyway, it was a fascinating exercise in watching my mind try to put a particular viewpoint on things just because it's so used to doing that. So that was a little bit mind expanding. The only other thing I'll say is that in my particular neck of the woods, in this particular latitude and longitude, the lilacs are just blooming. And so right after this call, I think I'm going to go outside and smell them. And I encourage anyone who is in a similar latitude and has access to these wonderful flowers to go and do the same, because they'll just make your whole day better.
Awesome.
Shelby Farrow just tweeted yesterday or a day or two ago that every once in a while I like to go outside and tell nature how awesome inside is.
All right, David, what are your picks?
I've got a bunch, so I'm going to move really quickly. I've already talked about the Silhouette and the Cricut. I'm a big fan of the Teensy USB development board. It's a tiny little programmable chip that comes with all the pins that you need to solder. You can get it with pinouts to plug it into an existing circuit board, or you can just get it with through holes to put wires on it. I built a little continuous integration spec monitor, basically. I just soldered LEDs directly to it because it was internally limited, and you plug it into the USB port, and I wrote a little RSpec adapter so that when I run my unit tests, the little green lights start cycling each time a test passes. I get, the green LEDs blink, and then if a spec is pending, the green lights go out, and now it's only going to blink in the yellow, and if a spec fails, then it goes to the red, and it runs that way until it finishes, and then red, yellow, or green LEDs light up and stay lit continuously to tell me what the output of that spec run was. And this is kind of fun because I can now stick this to my monitor, and I can have guard running without running any type of, like the growl on OS X or any of those things that pop up the message boards that tell you your specs failed or passed or whatever. Because I've got this really bright light on a physical piece of hardware, shining in my eyes and saying, oh, your specs are running. Oh, your specs are failing. Oh, and that sort of thing. It's a lot of fun. There is, I will pick these next three very, very quickly. When you start building circuits, eventually you're going to want to just go buy a bunch of electronics stuff, like resistors and diodes and capacitors and all that kind of stuff. And my three favorite websites for that are DigiKey, which is just a big superstore. It's like Costco for electronic parts. Another favorite is Mouser Electronics. That's Mouser.com. But the first site you want to check when you want electronic parts is allelectronics.com. And the reason why you want to check them first is they have, quite frequently, they get secondhand stuff in. So, at one point they got in just a truckload of old road construction signs, like the great big, arrow, blinking orange, yellows, merge lane ends, merge left, that kind of stuff.
That's
and
amazing.
They pulled all of the LEDs out of them, and they they basically say, these are like 10 bajillion candelas. Do not look directly into this LED with your remaining eye, because it's just they're just so insanely bright. They don't have them anymore because they don't have any more of the science. They sold all the parts. But if they've got them, they're cheaper there because they're usually refurbed or secondhand or salvaged parts. And then if they don't have exactly what you need, then I go check DigiKey or Mouser. My current favorite site right now, for larger scale tinkering, a little bit higher up in the intelligence scale. When I say intelligence, the complexity of the circuit that you're building, right? The how intelligent the computer you're playing with is. So you're going to step up to like the Arduino level is adafruit.com. That's ADA as in Lady Ada, adafruit.com. I just love everything about Adafruit. The way they are trying to get electronics into the hands of consumers and into people that don't know tons about electronics. I'll put a link to this in the show notes, but go to Adafruit and go to their wearables. They have two circuit, and they're little circular circuit boards. One's called the Flora and one's called the Gemma, and they are sewable microcontrollers. So they are designed, they're just these little pucks that you sew them right onto, your jacket or onto your sneakers or whatever. And then they make other little, in the same form factor, little sewable discs that you can attach to, clothing or whatever, that have super bright pixels on them, or a GPS receiver and transmitter. And they can communicate over, you stitch them on with conductive thread, or just, you stitch them down and then you string a little bit of wire between them. And then they start communicating with each other over like 800 megahertz radio frequency. So you can chain 20 of these LEDs together, and you don't have to wire them up. I mean, you have to wire them up correctly, but I mean, you don't have to do this big complicated circuit. You just build this little daisy chain, and then you program the Flora and tell it, hey, there's 20 of these little LEDs. I want you to change their color in this wave pattern. And the Flora knows how to do it. Okay, there's 20 of you, line up. Here's your color, your color, your color, your color. And they each pass the signal down. I mean, it's the technology behind it is mind blowing. But what it gives you is this little tiny thing that's an inch in diameter that you can stitch onto your sneakers and just twist 3 wires together and attach it to this puck and plug in a battery. And you've got an awesome circuit that you can wear and walk around in. It's absolutely just amazing. So I'll put a link to that. I love everything that Adafruit is doing right now. They're just crazy awesome.
A lot of those you can take the microcontroller out if you want to wash it. So it's actually it's not just like you're not just making like your Tron suit. You can like everyday wear.
They actually thought about what wearable means. That is so cool. That is so cool. And they've got dozens of projects, like skirts that light up with motion sensors, and sneakers that light up when you walk, and a jacket that has a GPS in it that blinks when you're at your destination, and just awesome stuff.
Are you done, Dave? Because I'm already poor enough.
Did I just scoop everybody else's picks? I certainly scooped everybody's wallets, right? Yeah, be careful with Adafruit. It's
like a crack habit.
Yeah, it's not really commerce. It's more like theft, because you can't not spend money when you go to this website. It's awesome.
Awesome.
Those are my picks.
Awesome. James, did we get your picks?
Not yet. This week is inspirational blog post week for me, I guess. I have 3 of them. First, in the recent rounds of debates going on in the Ruby community, we kind of touched on professionalism and what it is to be a professional developer. And that led Greg Brown, a friend of the show, to take and rewrite one of Uncle Bob's essays to show him how he thought it could be more professional. And Bob ended up largely agreeing with Greg, and they have this cool discussion. It's all in a gist, so I will link to it. It's amazing. You should go see it. Another blog post that really inspired me recently was a post about doing small projects. And when we say small, this person, Darius, is getting at about 73 a year, so a couple a week, and it's amazing. It's very mind blowing, and he talked about the effects of working at that smaller scale and what he's able to accomplish, and it was a very inspirational post for me. So I think you should check it out if that sounds at all interesting to you. And finally, I read a third post about micro-messaging, and it was basically about different ways to pass messages between 2 services. And it introduced me to some things I wasn't even familiar with, like JSON RPC I didn't realize was a thing, and that's kind of cool. And what I like about this blog post is Eric, the author, shows how to do the same example several different ways. So passing the message over Redis, passing it over RabbitMQ, and passing it using simple HTTP. So all of these blog posts were cool. If you're into those kind of things, you might enjoy them. That's it for me.
Awesome. I'm going to jump in with a couple of picks that are relevant to this. We kind of talked about robots, but we didn't directly address robots in depth. We did that on the JavaScript Jabber show. So Julia was talking about how that's kind of become a big thing in JavaScript, and it's true. And so, yeah, we talked to Raquel Velez over there. So if you want to listen to that episode, you are welcome to. And then another one, and this was Jameson Dance, who was also a regular on that show. He did a talk at Mountain West JavaScript Conference where he actually did a bunch of stuff with Arduinos. He flew a drone around the room and a bunch of other things. Anyway, if you're looking for some projects or some things you can play with or a good reason to go buy one of those drones, that's a terrific talk. And I'm probably just going to leave it at that. Julia, what are your picks?
Mine are, if you want to follow up with some of the stuff that I talked about, if you go to about Nodebots, and I posted some articles about like general trends in web developers getting into boards. And so there are those, and I put up my tutorial if you want to start programming your Arduino in Python, and I do point to some tutorials on Adafruit. And if I could take like a 5,000 foot view of the space, so that listeners can have a better understanding of all the various players in the indie hardware movement. So I often point people to Adafruit very frequently, if even beginners, because Adafruit I've found actually has some really great beginner tutorials. And Adafruit makes a lot of their own components and a lot of their own parts, so you can buy these really fully featured kits from them. And then once you graduate from Adafruit, you can then, I've noticed a lot of people then start buying from Mouser and DigiKey, because if you're buying a lot of components, it makes sense to buy them from some of those producers versus buying them in a larger kit, because maybe you'll need LEDs. So then you kind of graduate to that, and then you start to graduate to doing some of the stuff that we've got on Tindy, which is like for much more advanced folks. So you kind of got the whole gamut. And there's also a place called SparkFun Electronics. That I would heavily suggest, I would strongly suggest as another great place to buy components and to buy. SparkFun makes their own Arduino clones, because Arduino's open hardware. So I've noticed a lot of schools that maybe can't afford the $30 to $45 Arduino, depending on what you're buying. You can buy them in bulk from SparkFun for much, much cheaper. I've heard they're just as good, but they're not the Arduino board, but they're fabulous stuff. So I'd really suggest going there. That's like another place that's maybe on the more advanced, once you've got some momentum on your electronics projects. And I think that is all.
Awesome. Tons of cool stuff in this episode. So much fun.
Agreed.
Well, thank you guys so much for having me. It was so much fun to talk about.
Yes.
Yeah. Thank you, Julia.
Thanks for coming. You want to talk for the next couple hours? Because
I wish I could. I've got to deploy some code.
Excellent.
Back to software land, huh?
Exactly.
All right. Well, thanks for coming. We really, really appreciate it.
Oh, thank you guys so much for having me. Have a wonderful day.
All right.
You too.
This episode is sponsored by CodeShip. CodeShip is a hosted continuous deployment service that just works. Set up continuous integration in a few steps and automatically deploy when all your tests have passed. CodeShip has great support for a lot of languages and test frameworks. It integrates with GitHub and Bitbucket and lets you deploy cloud services like Heroku, AWS, Nodejitsu, Google App Engine, or your own servers. Start with their free plan. Setup only takes 3 minutes. CodeShip, continuous deployment made simple. A special thanks to honeybadger.io for sponsoring Ruby Rogues. They do exception monitoring, uptime, and performance metrics, and are an active part of the Ruby community. Hosting and bandwidth provided by the Bluebox Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more. Would you like to join a conversation with the Rogues and their guests? Want to support the show? We have a forum that allows you to join the conversation and support the show at the same time. You can sign up at rubyrogues.com/parlay.